in tailings dumps, love steam engines. I had at one time about 30 of them I pulled out of the mines. Still have a couple of steam engines. I have a steam tractor. But also, I was always interested in old machinery, electrical and otherwise. I started collecting, quote, quackery machines just because they shock me and I like it, or they throw sparks and I like it. And because of that, I've tried to find out how they work, why they work, and I've tried to find information on them over the years. One of my first machines was, we'll stand there, break Jeff's light.
There's a little button on the side.
There, was a Faraday battery. Again, I said, what's a Faraday battery? It's a car spark coil, it's a Romcom coil. Shocks you quite nicely. I played with it and I got shocked quite nicely. So I asked Jeff to put this slide back up because of this machine. Part of this conference, or all this conference, is right. So I started looking at things. I have an electrical engineer degree, and I semi-like physical science, biology, incorporate this. I also worked as an instrument tech in the chem department, so I worked on NMR machines, MRI, high vacuum, X-ray crystallography. Got my first X-ray tube when I was 16 from a high school. Got a lot of stuff from a high school. Maybe some of it they don't want to know what I got, but this machine's interesting in that this was one of the first attempts at frequency modification for therapy. This wheel here is called a rheon, and it would give a very low frequency pulse of high voltage. And it gave different physiological effects than on the other side. You can't see it in detail, but there's a flat metal rod, and you could adjust the tension on it, and it was like a buzzer, but you could change the pitch of the buzzer. So this side could give you anywhere from 500 to say 3,000 hertz of high voltage pulses. This side would give you about 4 hertz to half a hertz pulses. And what's interesting is these different frequencies would cause different physiological reactions. Low frequency pulses, you definitely would twitch, and you can't let go of these electrodes as you get them on you. But as the frequency goes up, you can start to stop feeling sensation and actually let go of these. They stop reacting with your muscles. In other words, the impulses are traveling faster than our nerves will react, so therefore it ignores them in a sense. So with collecting these, I got my first Hogan apparatus, which is a very fascinating device. Again, it shows high frequency electricity. Now, how high is high? Then 150 kilohertz was high frequency. This device had 3 coils. It had a Tesla coil right there. It had what they call a Wheaton coil there. The modalities are totally different between these 2 coils. One's much higher in frequency than the other. The high frequency or higher frequencies they use for different physiological effects or results in the low frequency. As Jeff said, they use these for lowering blood pressure. Modern diathermy or shortwave diathermy, they had cabinets called electric fevers, where they would stick the patients in to elevate the body temperatures to kill disease. They were relying on the biological effects to kill disease, i.e. a fever. They weren't relying on the electrical effects to kill the fever. They were relying to elevate your body temperature in hopes that it would kill the fever. These diathermies, most of the glass electrodes, same thing. They would insert them in various parts of the body and elevate the temperatures, and the higher temperatures would kill the bacteria or kill the virus. So they weren't used in a quackery sense. There were bona fide medical uses on them. Unfortunately, people grabbed these machines and ran with them, and they became total quack and total disallowed. The first diathermies were spark gap.
There we go.
First diathermy, as Jeff mentioned, was what they call a spark gap machine. And what that was, before vacuum tubes, the only way to generate radio waves was a spark gap and a resonant circuit. So they modified these machines. These are actually RF generators, but again, very low frequency. A megahertz max, 150 kilohertz typical. Now with these devices, they would hook the patients up. Now what's interesting is the patients were directly coupled to the high voltage and high currents. I mean, physically, metal electrodes with sponges and wooden clamps directly coupled to the device. And they were feeding amperes of RF energy into the patient. They found them very useful. What's diathermy do? Some of you probably know. Most of today no one uses diathermy anymore, but it's heating the body by radio waves or high frequency currents. And what they discovered is the energy would penetrate the skin and not be carried away by the blood, so they could get deep heating therapeutic effects. One advantage is, as Jeff mentioned, is surgery. Today, in virtually every skin doctor, if you go to it, you'll see a little box this big on the wall. It's called a hyfricator. It's still a high-frequency RF generator that they use to remove warts, skin cancer, everything. They still use these devices today. So there is something to their usefulness. The military still uses the device, and probably a lot of hospitals, the older ones especially, you'll find a bogey machine in the back room or in the corner. Again, for high voltage surgery for minimizing spreading effects of cancer and toxins. Now, I like these machines, so I started collecting them and trying to research them. So we go from the spark gap diathermy there, we go over to, which we'll show there, that was one of the first shortwave diathermies right there. It's a Fisher, it was made in about 1930. This is a later one. They had a vacuum, free-running oscillator, they called it. They weren't crystal controlled. They kind of generated RF noise all over the band. The very first ones operated in the 10, 11 meter band, 27, 29 megahertz. And later the FCC regulated the diathermy frequencies to around 10 to 15 megahertz. I don't remember exactly which. I have a crystal controlled one, which is legal. But what was interesting with the Faraday batteries with these machines, and even Tesla noticed that different frequencies have different sensations or different effects on the body. Well, I've started collecting this stuff, shortwave diathermy, spark machines, violet rays, and the biggest boondoggle was finding information, because no one knows about these things. So I've been trying to amass a collection of books and manuals. Jeff knows about these. I've copied them to Jeff. I've given Jeff some original books. But part of this deal and this conference is about Rife. So I've taken an interest in that section of it. Of course, some people call it a pseudoscience. Some people don't. I want to give you my take on Rife, because I've been asked about this by a number of collectors and a number of people. Because of my work in the university, with an MRI or an NMR machine, and gas chromatographs and other things, what do we know? We know that each organism or compound or something has its own resonant frequency. That's why a gas chromatograph works. That's why an NMR machine works. You put something in an intense magnetic field, you sweep the field, and you get spikes on a chart recorder. Kind of archaic in the old days because they're hard to interpret. The computers brought that on now to where we have a MRI where we can see a full body picture with every organ in the same device, an intense magnetic field sweeping a frequency. Well, Rife had the same idea way back when. And what we have to look at with Rife is what did he use, or what did he work with? There's so much misunderstanding, in my opinion, about Rife. We have to go back to what he worked with first to understand how we can improve it. Just like the Tesla coils. Cotton silk covered wire was a big key to making these things work. Various components or technologies or ideas are not taught in school anymore. They're lost. There's very few of us that have an interest in it, and a lot of the equipment is not available anymore. I'm going to move over to this table. we have a plan here. And, very first radio transmitters are nothing more than a modified Tesla coil. And modified meaning that they're very tightly tuned to give a very narrow band of interference. And that's basically the only way you can describe a Tesla coil, is it's an RF generator that gives a lot of interference. So to receive the very first radio signals, I brought this as an example. The radio receivers are very simple. Nothing more than a coil of wire of a specific length, a specific number of turns, but not super specific. Adjustable by making a wiper. That is a complete radio. We're only missing stripping the audio off the signal, which they did with a piece of iron pyrite, or as we know it as a galena detector, a cat's whisker. This would form a rectifying junction and strip the audio off the RF carrier. This particular example is also, and donations are accepted, this is also a bank, so we can listen to our music and save our money. As radio evolved, we get into the 20s, which is now the Rife era. Radio receivers were still very simple. Most of the time they were just a coil of wire with a coil of wire inside that rotated. This just changed the relative inductance and would change the relative frequency and make the set tunable. Later they got very exotic and they added variable capacitors, but they didn't like these because they're expensive. So this was the typical radio arrangement. This assembly is the guts of this radio. Now I have this radio here, as one gentleman here has a bunch of Kennedy equipment. This radio, I put it on its side for purpose. This is in one of Rife's pictures, as part of his equipment. This is a 1922 Westinghouse, which later became RCA, RADA. This side is a tuner. This side is just the amplifier to strip the audio out, and so you can drive a speaker. It's battery operated. It's supposed to look like this. And in here are 3 tubes just to make the audio and drive an old horn speaker. So Rife used this equipment initially to try and determine what? Frequencies. Now this is very limited because this early radio went from about 50 kilohertz up to what they thought was high frequency is 2 megahertz. And as Rife started looking at this stuff, I don't know the connection yet, and I've been trying to find a picture, but it's very obvious he associated for a while with a man named Abrams. Now Abrams is the father of radionics, which is still quite popular. This is one of Abrams' early devices, and I've taken the screws out so you can look inside carefully because the wires are still attached. But Abrams believed, as near as I can do, and I have 3 original Abrams books, that all life or all energies resonated, and for some reason he believed in the power of 10. These are decade resistance boxes from 10 ohms, 20 ohms, 30 ohms, 40 ohms, 100 ohms, 200 ohms, 300 ohms, 400 ohms. They're always powers of 10. Abrams went on to produce an oscilloclast. I always nicknamed them the tick-tock machine. Because when they ran this would tick-tock and this thing growls when it runs. And what's inside here, you can't see much, but there's a 1-turn short-circuited Tesla coil. There again is his resistance. If you notice, that panel is identical to this panel. This machine, because of a short-circuited Tesla coil and being driven the way it was driven, generated approximately a 42 to 49 megahertz rapidly damped pulsation. He later took this same machine and made an electronic version of it. And I didn't bring the electronic version because Rife, I cannot find any reference that Rife had that. But in one picture in Rife's laboratory, there is very, very definitely one of these Abrams tick-tock machines in his laboratory. So for something Rife did, he used this principles, this machine, to help build his Rife wave machines. Now Rife, of course, back then we had microscopes, and you all know his famous microscope, which is basically an electron microscope, only using optics. And he used interference, ultraviolet, and quartz lenses so he could see intense magnifications to determine his viruses. When he made his first tube, he took an X-ray tube. This is very similar to of the period. Actually, it's not. The tube he did use I wouldn't bring because it's too fragile. It wouldn't survive driving here. But he took an X-ray tube, which most people, the two Rife machines you have a similar. They have an angled target and an angle anode or cathode, whichever you want, and a straight cathode. There's no magic reason for that other than that was the shape of the first X-ray tubes that he did. He broke the vacuum out of this tube and he lowered the vacuum back to a Geissler pressure, i.e. that could be excited with low voltage and filled it with various inert gases. Now, it's my theory and my speculation that this tube is nothing more than an antenna. It's an RF radiator. It's a load on a circuit, they call it. You can't run a transmitter without a load. If you do, you'll burn the transmitter up. So, was using, as far as I can determine, was a 29 to 27 megahertz RF oscillator. From the pictures I could see and from the information I got, I think he used a diathermy. This is a shortwave diathermy, one of the first made that is vacuum tube. This is a 27 to 29 megahertz range. The patient is no longer electrically coupled to the machine. He's indirectly coupled just by resting on these pads. There's an insulated pad with a metal plate. And Rife connected that tube up to that machine. Now this is a custom-made Rife tube, quartz glass, that I got from some people you know, John Bendini. I have another tube, but I couldn't bring it right now. I met John because he lives where I live, and I had big arguments with him. Because the modern Rife tube machines, what do they use? They use a CB transmitter and they use a linear amplifier. And I told John, you're doing it wrong. He says, no, I'm not. I said, you're doing it wrong. Modern day electronics are solid state. Solid state devices are what they call current driven. They don't generate voltage, they generate high currents. The original devices, tubes, are voltage driven. They generate high voltage and not a lot of current. Now, so I gave John a shortwave diathermy. I said, you've got to try this. Because the linears that they put on these CBs are in the order of hundreds of watts, sometimes 500 watts, to excite the tube. This old shortwave diathermy, which Jeff didn't turn on, only puts out 25 to 50 watts. We're going to move that yucky stuff. Now, 25 to 50 watts, everybody says, that's not going to do anything. That lights the tube up better than 500 watt CB units. Because gas discharge tubes need voltage. They don't need current to excite them. You've got to get the energy levels up because the cascade discharges. So, you can still hear me, can't you? I don't think I blew it out. By detuning it, I can change the intensity of that. Now, I'm only putting like 25 watts in this. So John took a machine very similar to this, and he modulated it, which is what Rife did. He modulated a carrier wave, made a very controlled AM transmitter. And with my diathermy I gave him, he was getting better waveforms and better transmission of energy 15 and 20 foot away from them than these high-power CB units. So I've had interesting discussions with John over the years. He's built a modern version of the Abrams tick-tock, shall we say a solid state version, but he can't get it quite to duplicate the waveforms of an original. But that is my interest, and like I said, since it was Rife, this is some of the stuff I tried to pull together, is what Rife started with. It's basically spark gap, simple non-electronic circuits, electrical circuits, into, I know he used this frequency and a machine very similar to this for his first beam. Then he used very specific frequencies to attempt to kill very specific organisms. People have asked me, do I think it works? And I say yes, maybe. And the reason I say that is working with NMR machines and MRI, we can see these signatures, that's a kidney, that's a lung, that's a bones, by sweeping frequencies. I don't think it takes a leap of faith to make if we can define these frequencies to cause cellular destruction, organism destruction, aka actually curing something, if we can find the right frequencies. The big thing is there's a big misnomer on what frequencies to use. It's all shrouded, unfortunately, in mystery. The federal government came in. John was working in the lab when they raided the lab in California. You saw him throw one of Bryce's microscopes in the ocean. Yeah, I know, he's an interesting character, but he's also quite bitter. And so, you know, a lot of the information is lost, and again, it's been perverted. Like, these machines all had valid medical value, but over the years, they have turned into quacks. The wrong people have got them to the point where they're called pseudoscience, and it's hard to get recognized practical value out of these anymore. I've listened to part of the lectures. You know, you have to be very, very careful how you approach people. You have to be very, very careful how you document things. What you state it will and will not do, which is sad, because unscrupulous people have caused a lot of problems in industries. Not only electrical, electronic, medical, scientific. There's quack automobile stuff. I've got a ton of actually quack items for automobiles. A little glass vial of mercury you put in the radiator hose, which is supposed to stop the corrosion in your engine. So the quacks are everywhere in every form of every industry we know. But I wanted to show you, go back to basics, as Jeff said. Very little power. I got a very good discharge on a rife tube, very, very simply. But you can't use a later diathermy machine because they're down to 12 megahertz. You got to get an earlier diathermy machine or this design, and you've got a very simple machine that's very easy to modulate if you want to experiment with a tube-type device. And that's all I've got to say. We're going to fire some of these machines up. You can see early day electrocoagulation. We got a piece of bacon here that'll make you laugh and sizzle. With this machine here is approximately 1925, which was what the doctors used widely. I actually met a doctor in 1980 that was still using one of these machines in his therapy in Houston, Texas. He finally had to give it up because too many more people were complaining it was messing up their radios and TVs. Originally, as Jeff said, there was no radio when this stuff came out. Radio really wasn't in the home yet. So these were easy to use. No one had any hash to interfere with. But as radios came online, the FCC started controlling these things, making them tighter. They outlawed these because these basically go DC to light for noise interference. These weren't too bad yet. But as we started getting to short wave in the 30s, we started going up to 30 megacycles. We thought that was very high frequency. Well, then these machines started messing with that. And then, of course, in the 40s and the 50s, these machines basically became inoperable unless you're downtown in an industrial section way far away from residential, because they just wiped out the radios. And as television came on, all this makes the nicest black lines on television who's ever seen when I fire this up. And when you turn this on, it makes the nicest noise out of your stereo, and if you got a high-power stereo, it'll blow the speakers out. Some of my other diathermies, you fire them up, and I can draw arcs that far off the light fixtures. So it's quite exciting, but at the same time, you got to watch what you're doing. Fortunately, I live way out in the country, so no one complains. Yeah. And in closing, though, one thing we have to mention with quackery, there's one type of quackery that is absolutely amazing, and we like this one because it's totally different than any other piece of quackery we've owned. This is nicknamed gas pipe therapy. It's a cylinder with magical elements, typical coal dust. If you were to put this cylinder at a cold temperature, either immerse it in water, throw it out the window in the winter, you were to clip the electrodes to your ankle or electrode, clip this electrode. This was very specific. This one had to go to a pipe that went in the ground, not a radiator. It had to physically go in the ground. This was supposed to cause the body to generate oxygen and burn all diseases out. They're under a million different names: oxydonor, oxopathy, everything had oxy in the title. Japan made these devices in the 20s. I have a couple of those. We like this one because it is the identical machine, the identical philosophy, but backwards. It says electricity is bad for you. It'll kill you. You don't use it. So it's a total anti-electricity machine compared to all the others. Was a pro-electricity machine. The instructions are a hoot. You're supposed to never wear shoes. You're supposed to walk on bare feet and always be in contact with the earth to make sure you're always discharging any negative energies back to the earth. If you're in a house, you're supposed to go outside in your bare feet and walk on ground every once in a while. They're very specific about what water pipes to hook it to, what well water. If you use water, it has to be drawn from the earth. It shouldn't be through pipes to immerse that in. Preferably, you throw it in a stream if you can. Fascinating stuff, fascinating history and all this stuff, fascinating uses, fascinating beliefs. And again, some of it probably did work, if nothing more than the power of the human mind. Because the human mind is amazing. We can heal ourselves sometimes. The power of healing has to start up here. Then assistance through either biology or chemistry or physics or whatever can promote it, but the mind is a big key to making us feel better and making us heal faster. So that's all I have. Because I'm going to have to take the mic off when we start running some of these machines. I know it'll blow up the wireless mic. We've already done this. We'll demonstrate this stuff for you. You're welcome to come up and ask questions, play. If you're happy to turn these back on, you're going to see this guy work. Anything over there on the TikTok, you're welcome to look inside and see how it... Now the TikTok is kind of interesting. I didn't disassemble that one. There's wood in there to hide the guts. I had another one where the nails were pulled out. I have not disassembled this one anymore in the cupboard. But there is a Tesla coil in there. There's a coil this long, about that big around. You can see a big disc. That's the primary for the Tesla coil. This is the Tesla coil, so that's the primary. That's what you see. And these windings are hidden. And that gives a ringing frequency, like I say, of around 49 megahertz. And did it work? I don't know. Does it work? It does something. Electrically, this device is a motor generator. It gives varying waveforms up to 100 volts. Sinusoidal, AC in other words, pulsating DC, DC on top of AC. This machine was again thought to cure a lot of ailments. However, it still has its origins today in physical therapy. It TENS machines and some other devices they use to check your nerves. So they'll put 2 electrodes on and they'll go down your arm if you've got a broken arm or something to where it stops working. So they can tell the nerves where they start and stop, where there's physical damage. They use these TENS, transneural stimulation, is a Faraday battery we had up there. What does it do? What they found out it does is the nerve is an electrical transmitter, which I'm probably most of you know. But after a while, if you continue to stimulate it, it stops working. It stops sending sensations. So a TENS machine blocks pain by constantly stimulating the nerve to the point where electrically it can't work for a while. It goes dormant. The pain is blocked. The Faraday batteries in these, they thought cured you because it blocked the pain by overstimulation of the nerves. Of course, after a while, the nerve will recover and the process will begin again. So you basically are hooked up to these machines for life. I have the Faraday batteries. I have one of the first TENS machines made, and I have some of the modern TENS machines. So I've looked at those, and I've tried to pile this stuff together over 150 years worth of history and why this stuff works. That's all I have to know. So I get very cautious where metal is around these, and Jeff can attest to that too. We both. And the other side is a needle, nothing more than a needle or sometimes a spoon-shaped thing. The electrodes are very simple. They were a piece of aluminum rod, bent, shaped, tapered to the type of surgery you wanted to use. Let me do. There. Now I turn this machine on. It's that circuit, only older. There's a spark gap in here. You can hear it hissing. And when you touch the patient, it's an RF energy, and it's not cooking the meat very good. I gotta turn way down. That's, oh, I can smell it. Oh, I can smell that.
Hey, do you have a license to do that?
Okay, now we're surgically cutting the bacon. We're cauterizing at the same time as we're removing. I can say these machines are very popular in operating rooms, especially the Bovie machine. One of the problems we had in the early days, of course, what was our common anesthetic? Chloroform or ether. What happens when you get sparks around ether? You had nice little explosions. When I picked it up, it was in my truck, I brought it over here and turned it off. There's been no restoration, no nothing to this device. Same, and it is a Curtis coil from one of his 1920 books? 1915 books. As close as we can duplicate with copper primary, strap copper primary. The secondary, that wire is almost the identical diameter of wire. The coil form is almost identical. Again, Jeff made this. It was a nice gift to me, and I brought it over to the thing exactly like he did. Interspaced cardboard in between as insulators for the copper strap. It was a chore rounding up all the original parts for these, but we finally got it down to a science. And somebody you come behind you. It's generating RF energy and it's arcing to a metal slot in the back of the table. I can see a blue glow underneath these. Again, these are very effective energy